Hello again, everybody. Today we're going to discuss the Fibonacci betting system as applied to roulette. And Fibonacci system is based on the Fibonacci series, which is credited to a gentleman named Fibonacci in a book he wrote, generally known as the Book of Calculation, in the year 1202, so over 800 years ago. And that book was really a milestone in mathematics. It introduced the Arabic numerals, so it began Europe's move away from Roman numerals. It introduced decimal notation. It was used widely for understanding how to compound interest. So it was really a seminal book in terms of mathematics. And today we're going to look at the Fibonacci betting system. Let's begin by looking at what a Fibonacci series is. So what you can see here is a Fibonacci series, and generally it's understood to start with the number 0, 1. So those two numbers are given, if you will. And then the way the Fibonacci series works is the next number in the series is always the sum of the prior two. So 1 here would be the sum of 1 and 0. 2 would be the sum of 1 and 1. 3 would be the sum of 2 and 1, and so on and so forth. And you can see that this series does grow bigger and bigger. It actually continues to infinity. I've only written the first 20 or so digits of it here. But this is what's known as the Fibonacci series. And one of the interesting things about the Fibonacci series is if you were to look at the ratio of a particular number in the series to the number just prior, like, for example, here, 1 divided by 1 is 1, of course. 2 divided by 1 is 2. 3 divided by 2 is 1.5. And 5 divided by 3 is 1.67, and so on. And if you were to look at that ratio of a number to its immediately preceding number, all those ratios are written here, you can see that it looks like it converges. And indeed, it does converge. It converges to this value to 6 decimal points, 1.618034. And that may not mean much to most of us, but it's actually a really interesting number. It's actually known as the golden ratio. And let me explain what that means. The golden ratio was posed in this way. So assume you have a length of, let's say, a stick or a ruler of a certain length here. And you want to divide that ruler up into two pieces such that the ratio of A to B, in other words, when you divide it, the ratio of the longer piece to the shorter piece is equal to the entire length divided by the longer piece. So if we were to express that algebraically, we would say A plus B, which is the length of the whole stick, you will, or ruler, divided by A. So the length of the whole thing divided by the length of the longer piece is equal to the length of the longer piece divided by the length of the shorter piece. And the rest of this is just algebra. So A plus B, the quantity, divided by A is just 1 plus B over A. So 1 plus B over A has to equal A over B. And then to simplify things, I'm going to just let Z be equal to A over B. So then on the left-hand side, I have 1 plus 1 over Z. And on the right-hand side, I just have Z. So now I have this expression here. If I multiply both sides by Z, I will then have Z plus 1 equals Z squared. Rearranging this thing, I get Z squared minus Z minus 1 equals 0. And many of you, if you hearken back to high school algebra, will recognize this as a quadratic expression. And there was something we all learned called the quadratic formula that allows us to solve this directly. And plugging into that quadratic formula, that is this expression here. And so Z actually, if you simplify, equals this. And because we're actually talking about lengths or distances here, we don't need the negative solution here in terms of the 1 minus the square root of 5. So if we just look at 1 plus the square root of 5, all divided by 2, that happens to be 1.618034, which is exactly what the Fibonacci series converges to in terms of the ratio of a particular element of the series divided by the immediately prior one. So it's interesting that the Fibonacci series is related to the golden ratio. Okay, well, we've had a look at the Fibonacci series. How do we apply this to roulette, to a roulette betting system known as the Fibonacci betting system? And as I begin, I want to say that the Fibonacci system is used on one-to-one paying bets like red or black, 1 through 18, odd or even, those kinds of bets. So in this particular case, I'm going to remove myself so we can see what's happening a little bit better here. The Fibonacci series you can see here down the left-hand side here in this first column. And so these are the values that we looked at earlier. And again, it starts with 0, 1, and then each element of the Fibonacci series is the sum of the two prior. And so it just kind of grows like that. And you can see, for example, here 34 is the sum of 21 and 13. 55 is the sum of 34 and 21, and so on. And so what happens in what I'm going to call the traditional Fibonacci betting sequence, which is that you start with this 1 here. So we're going to be looking at these values. So what happens is you initially bet 1. And if you lose, you go to the next number in the Fibonacci series to know how much to bet. So if I lose this first bet, then I go to this and I will again bet 1. And if I lose, I go to yet the next number in the Fibonacci series, so now I have to bet 2. And if I lose that, I have to go to the next number, so now I will bet 3. Now, once I finally win a wager, I drop back 2 positions. I drop back 2 positions in the Fibonacci series. So in this case, after having won this bet of 3, I will then drop back 1, 2, all the way to this 1 position here, and I'll bet 1. And let's say I lose that, then I have to bet 2. If I lose that, I move down and bet 3. If I lose that, then I move to the next one in the series, I bet 5. If I win that, then I will again go back up 2, and I'll bet 2. So this particular depiction here that I have, I've color-coded losses in red and wins in green. And of course, you may win or lose at random in roulette, and so this would be just an example of what might happen. But you can see that what tends to happen, and I've tried to make this a little easier to understand. So if you lose, you're just going straight down, and when you win, because you're jumping somewhere else now in the Fibonacci series, I'm moving it to a new column. So this win of 3 here means I have to now bet 1, so that starts this new column, and so on and so forth. So this one here, where I won the bet of 8, I go back up 2 positions. I now have to bet 3. If I win that, I go back up 2 positions, which would be this column, and you can see that in this particular example, I proceeded to lose a number of bets in a row. I have to bet 21 down here, happen to win again, lose, win like that. And what's interesting is at the bottom of the column here, I have the result for each particular column. So you can see that the win here at the end of this series, 3 losses followed by a win, I'm still -1 for the series so far, even though I won the last one. And for this particular series here, until and including my win, I'm at -1. For this particular series, I'm at -2. This one I happen to win right away, so I gained 3 units. This one here, my net for that is -11, +8, and so on. And if you were to add all of these up, what you would find is that it sums to 0. And that is interesting, but the reason that occurs is that as you can see here, when I win this bet of 3, because it was the sum of my prior 2 wagers, and I had lost those 2, this 3 will cancel out those 2. This 5 will cancel out the 2 and the 3. This 8 will cancel out the 5 and the 3. This 3 will cancel out this 2 and this 1, for example. And you can see here, if you were to look at this and maybe pause this video and convince yourself that this 21 cancels out these 2, for example. This 8 cancels out these 2. This 5 cancels out this and this, and so on and so forth. That everything cancels each other out. And so the way that you win, or the wisdom, if you will, if you want to call it that in the Fibonacci betting sequence, I would not personally call it wisdom. As we'll see, the sequence is not a winning system. It is still going to lose because roulette still has a house advantage. But the wisdom, if you will, or what the thought process is behind this, is that you're increasing your bet as you're losing, kind of making up for those past losses once you finally win, if you win. But as you might suspect, This system, if you do encounter a string of losses that continues, or perhaps a string of losses and then you win once or twice and then have another string of losses, because you need to keep increasing your bet after a series of losses, this particular betting system, the Fibonacci betting system, is subject to rather large losses, catastrophic losses, you might say, in terms of risking your bankroll. So what I did is I went ahead and coded up this system and just decided to let the computer do the work for me. And when we let the computer do the work for us, what's interesting is we could play a lot of games very quickly, and we can see what's really happening in this system much faster than if I were to spin a roulette wheel and actually try it out. So let's take a look at some of the computer results. Okay. So what we have here is a close-up of the computer simulation results for one particular simulation. And let me tell you how the simulation functions. So it begins with a bankroll of 1,000 units. And it wagers using the Fibonacci system that we've been looking at. So it begins with a wager of 1 unit. If it loses that, it will stay at 1 unit. If it loses that, it will then go to 2 units, which is the sum of the prior 2, and so on and so forth, just like we've been describing. It will continue to wager until it either doubles the bankroll, gets to 2,000 units, or it loses everything and ends up with a bankroll of 0, so it gets wiped out. Now, if it gets let's say near 0, and the wager calls for a particular wager and it doesn't have enough of a bankroll left, what this particular software I wrote does is it goes down to the last Fibonacci wager in that series that it can do, that it has a bankroll to make that wager. So that's the way this software functions. This particular output is helpful for us to A, make sure we understand what's happening in Fibonacci, and B, make sure the computer is actually doing the correct betting sequence. So what's output here in this graph is your bankroll after a particular wager number. So for example, after the first wager in this simulation, the computer lost the first bet. So now instead of a bankroll of 1,000, which is what we started at, we're at 999. In the Fibonacci series, we would then make another 1 unit bet. We happen to lose that one as well. So now we're at 998. In the Fibonacci series, we would now bet 2. We lost that, so we're at 996. Fibonacci now calls for a wager of 3. In this particular simulation, we won that. So we ease back 2 positions and then bet 1. And we happen to win that, so we're back to even to the 1,000. And so you can see that what happens here is this would be a series of losses where I'm continuing to increase my wager. So for example, here I'm at 993 units. After losing the next bet, I'm at 988 units, so I just lost 5. My next wager will be 8. I lost that, so I'm at 980. So now I've got to bet 13. I lost that, so I'm at 967. And now I've got to bet 13 plus 8, 21 units. And in this particular case, we won that bet. So we jumped from 967 back up to 988. And because we won that bet of 21 units, we're going to pull back 2 positions in the Fibonacci series. So we're going to pull back to 8. And in this particular case, we again lost the 8. So we ended up at 980. And so it goes. And what's interesting in this is you can see that there are certain bankrolls, 967 units, for example, that I hit upon from time to time. I will hit 967. I will not hit 968 or 966, at least not here near the beginning of when I start this. Similarly, I might be at 980. And you can see there are several points at 980. There are several points at 988. And the reason for that is the Fibonacci series, they're discrete numbers. 1, 1, 2, 3, 5, 8, 13, 21, 34. And so I'm betting precise amounts up and down. And if I lose, I'm betting precise amounts as I increase my wager. If I win, then I'm go ahead and jump back to, but I'm still betting those precise amounts. I'm staying on the Fibonacci series. And so my potential bankroll here at the beginning, as I begin my wagering, becomes somewhat discrete. And you might say, well, doesn't it kind of always stay that way, Olaf? Well, no. If I do get back to 0, and here I'm all the way back to 1,000. So this long sequence here just brought me back to 1,000. And so if anytime I'm back to the starting bankroll, if I started at 1,000, I make it back to 1,000, then I'm back at the beginning of that Fibonacci series sequence betting. So here I'm going to bet 1. And if I win, then I want to move back 2 positions, but I can't. So I just stay at the beginning. I bet 1 again. And so that's the way I can actually slowly increase my bankroll in Fibonacci. And let's say I'm here at 1,002, and then I proceed to lose. Then I'm going to hit different discrete points than I did here, where I started this at 1,000. So in Fibonacci, I'm hoping to win and recoup my losses at the end of a string of losses. I'm hoping to get those wins at the end and get back to the 0, and then have, just 1 unit incremental wins from time to time that slowly increase my bankroll. Okay, well, let's take a look at the bigger picture as I do some rearranging here on my screen. And what I'm going to do is I'm going to bring in some actual sim results from the entire run, the entire simulation run. And let me also remove myself here so that it's a little bit easier to see. And so this would be the result of 4 particular simulations. So you start with a bankroll of 1,000. And again, the simulation runs until you either double the bankroll to 2,000, and you can see the green guy here did make it. He did double hit the bankroll. Or until you lose it all. And you can see here the red one, the orange one, and the blue one each lost everything. They did not succeed in doubling. And so it has this general kind of upward trajectory of a shape. If you're winning, or if you can win at the beginning of the sequence, you're just kind of moving up here 1 unit slowly. But you are subject to these rather large dips here. So in that sense, it's not unlike a martingale system where you're kind of losing and hoping to recoup those losses. It's different than the martingale system, but these plots here, if you were to look at my video on the martingale system, you would see that this, in a rough sense, is somewhat similar in terms of this upward trajectory if you can maintain it, but you're always subject to these large losses which may wipe you out. Interesting here, the orange particular simulation was winning for a while. And so if you were, just looking at the system and you were playing in a casino and you said to yourself, well, maybe this system is a winner. I mean, maybe this system is actually a winner for me. With the orange chart here, you would see that you could have played 1,000 or more spins, almost 2,000 spins here, and be thinking, well, this is the greatest thing I've ever seen because I'm just winning, winning, winning. But once you encounter that large loss, you're in trouble. You may be wiped out completely, like this guy in the red simulation, or in orange here, he managed to recover. And then again started this upward trajectory, but then the next time he hit a series of negative spins, a series of losses. It wiped out Orange's bankroll. And so this system, like any system where you're up against a house advantage, is not going to turn the game into a winner for you as a player. If the casino has a built-in mathematical house advantage, then over the long run, you as a player must lose. There's no betting system that you can concoct that will turn a house advantage into a player advantage just by virtue of how you bet. I hope you enjoyed this video. I enjoyed making it. If you have any comments, please leave them. And if you enjoyed the video, please consider subscribing. May God bless you.